Okay, in this video on solving systems using substitution, we're going to look at one method where we replace one variable with another. Now, in any system, we talked about this a little bit before. The goal to solving a system, and again, a system is where you have multiple things you're solving for instance, two variables, x and y, and you need multiple equations to do that. Well, in order to do that, no matter what method you use, you have to eliminate one of the variables, so you're down to one variable with one equation. For instance, if we can get rid of the y's and only solve for the x's, then we can solve for x's. Then we plug it back in or evaluate and we solve for the y's. So you're basically solving for one variable at a time. So this first method, substitution, we are going to replace one variable in terms of another variable. Okay, so that's what we're looking at here. So let's go ahead and take a look at some examples to better explain what's going on here. So let's take a look at this one. Now, what substitution looks good is when we have a single variable by itself. So notice the y is by itself. Y is equivalent to -10. So every time I see a -10 or a y, I can replace with -10. So where do I see a y in the other equation? Right here. So I'm going to take -10 and plug it in for y. So I'm going to rewrite the top equation as 10x plus 2 times something equals 10. So instead of writing y here, I'm going to plug in -10. So -10 goes right here because -10 is the same as y. Now notice we have one equation with one variable, okay? And this we can solve. So let's go ahead and solve that. So we have 10x and distribute, so you have -20 equals 10. Move the 20 over to the other side, and we have 10x is equal to 30 divided by 10, and x is equal to 3. Okay, so again, our answer is going to be an ordered pair. So we know the x value is 3, so now we have to still solve for the y. So I'm going to take 3, and I'm going to plug it in. Okay, now again, we can see y is always equal to -10, but I'm going to show we can plug it into this equation. So 10 times 3 plus 2y is equal to 10. Once again, we have one equation with one variable, so this is solvable. So 30, again, let's do one thing at a time. I'm going to subtract 30, and we have 2y is equal to -20, and then last divided by 2, and y is equal to -10. So you plug in -10. And notice, that's what it says, y is always equal to -10, so it checks out for both equations. So right here is the answer to our solution. 1 point, one solution at the ordered pair, 3, -10. All right, let's take a look at another example. So again, identify what's easy to substitute. Y is equivalent to 2x plus 3. So again, let's identify the y right here, and I'm going to replace it with 2x plus 3. It's going to go there. So I'm going to rewrite this equation. So we have 15x minus 5 times, and instead of writing y, I'm going to write 2x plus 3 is equal to 30. Again, one equation, one variable. Notice x's is the only thing in here. So let's go ahead and solve for x. So I'm going to distribute -5, which is -10x. -5 times 3 is -15. Okay, I'm going to combine like terms, which are there. So that's going to be 5x, 15 minus 10. Write everything else down. Notice I keep it nice and organized. Next, I'm going to move the 15 to the other side equation. Okay, and 5x, the only thing left over here, 45 divided by 5. Again, you know, a lot of longer process here, but that's okay. And x is equal to 9. Now again, I always like to go and write my answer as x equals 9. Now again, we don't have to solve for x first. So this so happens that it was easy to get rid of the y's here. So now let's solve for y. So I'm going to take this equation and say y is equal to 2 times x plus 3. And in this case, 9 is equal to x. So put 9 in. And we get 18 plus 3. And y is equal to 21. So the answer is 9, 21. Okay, let's take a look at this last example. Okay, now here what we're looking to do is we want to get one of the variables by itself. Now, the only variable that doesn't have a number in front of it is this one. So it'll be easy to get this variable by itself. So I'm going to solve for y by moving 6x to the other side of the equation. So y is equal to negative 6x plus 2. Okay. Now, y here and here is equivalent to negative 6x plus 2. So I'm going to take that value and I'm going to plug it in for that y. So let's rewrite the top equation. 4x, the only thing I want is x's. And instead of writing y, I put parentheses. So see, I just basically rewrote the equation. Instead of writing y, I put a big parentheses. Now I'm going to plug in negative 6x plus 2 because that's the same thing as y. So let's go ahead and solve one equation, one variable. So 4x minus negative 3 times negative 6 is positive 18x. And then distribute, so negative 6, right? Negative 3 times positive 2. Combine like terms, so that's 22x. Next thing I'm going to do is add 6 to both sides. 22x is equal to 11 divided by 22. And x is equal to 1/2. Okay, so we know our answer is 1/2 comma something. So I'm going to take either equation. I'm going to take, let's say, this one and solve for um, y. Or I could, take this one here. I always like to put an original equation, make sure I did everything right. So I'm going to do 6 times x plus y is equal to 2. I'm going to plug in 1/2 for x. So 6 times 1/2 is 3. Subtract 3. And lastly, y is equal to negative 1. So there is our answer right there. Okay. So notice in all of these cases, we isolated one of the variables and we substituted it into the other equation. Let's take a look at some problems I'm going to have you try. So I want you to try these three on your own. So first go through and identify what variables would be good to solve for. So here, notice y by itself, y by itself. Now in this case, notice you have to get one of them by itself. So in this case, let's get x by itself. Let's show you that it doesn't always have to be y. It can be x as well.